All right, now we've talked about scatter plots and how to make scatter plots and what they mean. Now let's talk about another way to use scatter plots that uses a tool that we've learned about before. So first of all, we want to talk about what we mean by a line of best fit. A line of best fit is a straight line that best represents the majority of the data on a scatter plot. Sometimes we call it a trend line. It helps us predict values that are not displayed on the plot, but it will also show a trend. We use the equation y equals some number times x plus or minus a constant to describe the line. Remember y equals mx plus b? We covered that a lot in the past. The line may pass through some, none, or many of the points, but we will still use the data from the points to help create this line. So here's what we do. First of all, remember a line of best fit looks something like this. This one has a pretty good linear correlation. And so a line of best fit looks like this. A line is drawn through the data and it approximately cuts the data in half, above and below. Here's a couple of other lines. Which is the best line of best fit when you look through there? Well, you notice this first one, the line doesn't even go in the same direction that data is going. This next one, the line has a good slope to it, but it's above most of the data. And the third one, this looks like a pretty good line of best fit. It's coming down through the data, same slope and approximately same number of dots above as there are below it. On this next one, the line cuts through the data, but the data is kind of separated left to right rather than above and below. The same with this one. So the fact that the line doesn't have a good slope to it. It doesn't go up through the data with the same slope. In this case, this line of these three, of the ones game played, looks like the best line of by the best fit, the best example of that. So remember that when we write an equation of a line of best fit, it's going to like our old friend y equals mx plus b. And you got to pay really close attention, and you'll have a great line of best fit when we're done. So first, choose any 2 points on the trend line and set up a ratio of rise over run to find the slope of the line. And then look at the y-axis and find where the line of best fit intercepts that line. And that will be our b value or our y-intercept. And then you write the equation with y equals the slope that we found and b the y-intercept that we found. So let's write an equation in slope-intercept form for the trend line below. Well, if we look at our data, first of all, we notice that this line actually intersects the y-axis at 8. So let's go ahead and take that into account. Get our marker here. So in this case, b equals 8, right there. Now let's use that and another dot somewhere down the line to help us find the slope. Well, I notice right here that we go across a nice intersection. Sometimes we call it a crosshair. And it's okay if we come this far to find our line of best fit. So to go from here to here, we have to drop 2, or it's actually 3. So our rise is actually a fall of 3. And then our change in x, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a change in y of 9. So that's our rise. Our rise over run is negative 3/9, which simplifies to be negative 1/3. So let's write our line of best fit equation. Y equals negative 1/3 x plus 8. There we go. Okay, on our next one, we have a y-intercept or a b value of 60. And let's look up through here. We're going to use this as one of our points to help us find the slope. As we come up through along this line of best fit, I notice that the line crosses a crosshair right there at 2,80. So if we think about it, our change in y to go from here up to here is one step, which in this case happens to be 80. So change in y is 80. That's the number on top. And then the change in x to go from here over to here to get to that point is 2. So our change in y over the change in x would simplify to be 40, or 40 over 1. So our equation then would be y equals 40x plus our y-intercept, which was 60. Now you notice some of these numbers are bigger than what we're used to, and that's okay, because we're looking at real data now. These numbers are going to reflect real data that we might want to use. Okay, our next one, we have a y-intercept. The line crosses the y-axis, actually starts at the y-axis at 9. And as we follow it down, we look for another crosshair there. Oh, there's another crosshair right there. So to get from here to here, we have to drop 1, 2, 3, 4, 5. So our slope of this line is -5 over 1, 2, 3, 4, 5. Oh, look at that. Our slope is -5 over 5. So there's that ratio that we were told you to create, which simplifies to be -1. So then our line of best fit equation would be y equals -1x plus 9. And that would be the equation for that line of best fit. Very nice. Okay, so practicing writing and applying the equation of a trend line. The scatter plot below shows the number of items in a load of laundry and the number of minutes it takes to fold the laundry. Use the data to write A through C. Write a trend line equation. Specify what variable represents in the context of the situation. All right, so we're going to go ahead and write, first of all, our y-intercept, which we'll use B for. And that starts right here at 0, 0. So basically what we're saying is that if you don't spend any time folding laundry, you don't fold any clothes. So 0 time, 0 clothes. Okay, so let's follow our trend line up till we hit a crosshairs right there, which means that we fold 20 items in 10 minutes. You see that? So our y-intercept, our slope in this case, or not, our y-intercept is 0, our slope, sorry, means that we can fold 10 items in 20 minutes, which if we simplify would be m equals 1/2, meaning we would fold one item every 2 minutes. So use the equation to predict the time it would take to fold a load of laundry containing 60 items. Well, first of all, we got to finish our equation here. Y equals 1/2 x, and then remember we had a y-intercept of 0. So y equals 1/2 x, and we're going to put in for x, we're going to put in the number 60. So 1/2 of 60, it's 1/2 times 60 equals 30. So to fold 60 items, it's going to take 30 minutes. That's what that amounts to. Okay, it took Joey 22 minutes to fold a load of laundry. Use the equation to predict the number of items that was in that laundry. So that means for y in this case, we know that the number of items is 22. So it took 22 minutes, excuse me. So we're going to use our equation now to find out how many things were in this load. So we have 1/2 x equals 22. So we need to divide both sides of this equation by 1/2. And then when we do that, the 1/2s cancel out, leaving us with the number of items in the laundry. 22 divided by 1/2, if you do that on your calculator, would equal 44. So the number of things that he had to fold was about 44 of them. That's why it took him a half hour to do it. Okay, well, that's why it took him 22 minutes to do it. All right, let's do another one. A scatter plot shows the result of a survey where students were asked the number of minutes they studied in a science exam and their score on the exam. All right, so for our y-intercept of our line of best fit, we have a y-intercept of 60. And as we follow up the line to try and find another dot we can use to help us find the slope, I notice right there we have a crosshair point where it crosses this crosshair. And that is at over 20 and up 20. You see that? Over 20, up 20 to get to that point. So then our slope is 20 over 20, which equals 1. Which means that for every minute I study, my score goes up by 1. That's interesting, huh? So our trend line or equation for our line of best fit would be 1x plus 60. So based on what we know, or whoever's taking this test, they should get a score of about 60 because of what they already know. So what kind of a score can we get if we study for 30 minutes? Well, we put in 30 in for x, and 1 times 30 is 30, and 30 plus 60, the score we would already normally get, because we already know it, our score is going to end up being 90. All right, Trenton still needs to take the exam and wants to score 100. How many minutes will he need to study to plan on to get 100 points? So we're going to start out by saying, here's the score he wants to get. And we don't know how many minutes it's going to take to study. But if we fill in the rest of the equation, we notice that we have to subtract 60 to get to the answer that we're looking for. So 100 minus 60 ends up being 40. And so that means that he will have to study, Trenton will have to study about 40 minutes if he wants a chance to get up to 100 points. All right. On this particular one, this is something that you might see on the assignment, on Alex's assignment. It says, what is the predicted heating cost for a month with an average temperature of 0 degrees? So if you're already given an equation for the line of best fit, this equation already has some important details on it. You'll notice that if you continue that line up to the y-axis right there, that it intersects that 97.3. And if we could measure the slope on this, we would notice that it's negative 1.23 for every one that we go over. So that's just some general information I can get from this. So let's just state then that if we put in 0, no time, no temperature change, then what would be the monthly cost? And that would be $97.30. What if we had a temperature change of 25 degrees? Well, that would reduce the amount of heating that we need to do because the air would be cooler. And so if we did that, then it would, the cost to heat the house would be $66.55. So quite a bit cooler, or quite a bit less than what it would cost for a more expensive, a much more colder time when the temperature is 0 degrees Fahrenheit, which is really cold. Okay, so for an increase of 1 degree Fahrenheit, what is the predicted decrease in the monthly heating costs? Well, it turns out that if we put in 1 into our equation and then crank out the answer, we notice we get 9607, which is really a decrease in temperature and heating costs of $1.23, which happens to be the slope on our line of best fit equation. So watch out for those. Those answers are embedded right within the equation. You'll probably see some of them. Okay, so let's remember, what is it? How do you draw a line of best fit? Well, you draw a line of best fit. You find 2 crosshair points and use them to determine the slope. So you find one down here. Sometimes it's the one where it crosses the y-axis. And then you work your way up until you find one where it has a nice intersection. Then determine the y-intercept. Well, you use those 2 points to find your rise and your run. So in your rise here, that would be to go from here all the way up to here. That would be 70, 80, 90. That would be a rise of 100, right? So the slope of this line would be 100, an increase of 100 over 8, because you want to go over 8 on your graph to get there. So 100 over 8, which is 50 over 4, or 25 over 2. So it comes out to be about 12.5 for 1, right? So the y-intercept in this case was at 0, 0. So our y-intercept is 0. So if we write an equation for the line of best fit, 25 divided by 2 is 12.5. So we're going to have y equals 12.5x, and a y-intercept of 0. So now if we use that to predict the distance traveled in 10 hours, we would just stick in the number 10 for x. We'd have 12.5 times 10, which equals 125. So in 10 hours we should be able, or 10 units of time, well, 10 hours we would expect to go 125 miles. Well, that's pretty good, huh? Okay. How about in this case? So to do what we're talking about, you use 2 crosshair points. In this particular example, they used 2 different crosshair points. They didn't use 0, 0. So they ended up with a slope of 90 over 8, which is 11.25. So if you do that, 11.25, then your y-intercept would be about 0. So they could end up with y equals 11.25x plus 0, which is a little different than what we got here, right? So depending on what 2 points you use, you could end up with a little bit different slope. So you got to watch out and be careful how you do that. Okay, we want to write an approximate equation for this one. So to do that, we're going to draw a line of best fit. So to do that, we come up here, and I'm going to start somewhere on the y-axis and bring it down. I'm going to start right about 28, and that looks like a pretty good place to start. And then come all the way down to that 32. That looks like a great line of best fit. So my slope then, I'm going to go from here down to 0. and then from 0 over to 32. So my slope is going to be negative 28, because that's how far I'm dropping over the length of this line. And I'm running 32, that's going to be my run. So if you simplify that, negative 28 over 32, let me get my calculator. So if you do it on a calculator, you can go 28 divided by 32, and that is 0.875, and because it is it's going down, it's a negative 0.875. So our equation then is y equals 0.875x, and it's a negative because it's going down, plus our y-intercept we started out with was at 28. So now if we take 12 and plug it into that equation and crank out the numbers, you would do negative 0.875 times 12 plus 28, and that would give you 17.5 hours. So that's kind of telling you, you can kind of predict about how long someone was watching TV, right, in this case, right? All right, so this is kind of summarizing what we did. We used these 2 points as our crosshair points, and then we determined our slope and our y-intercept, and remember our slope in this case turned out to be negative 0.875, negative 0.875, then our x value, and then our y-intercept was 28. And when we calculated about how much it would take for 12 hours, we just did negative 0.875 times 12 plus 28. And that's how we got our answer. Okay, we got this last example. So a scatter plot shows the number of years of experience X and the hourly pay rate Y for each of 25 cashiers in Texas. So using the equation of the line of best fit, what is the predicted hourly pay rate for a cashier with 9 years of experience? So according to this equation, that means that the person starts out at $8.08 an hour, and then every year they get a 92-cent raise. That's what we have, like 0.92x. So if we want to know what it's going to take to get what you'll have if you're working there for 9 years, you're going to go 0.92 times 9 plus 8.08. So let's calculate that. 9 times 0.92, and then add 8.08 to that, and we would get an hourly rate of 16.36. So, there was a time when that can be considered quite a bit of money, but now that's a modest amount of money. What is the predicted hourly pay rate for a cashier who doesn't have any experience? Well, we just mentioned that if you don't have any experience, that would mean X is 0. So this part would be 0. So your beginning pay would be $8.08 an hour. For an increase of 1 year of experience, what is the predicted increase in the hourly pay rate? Well, that magic number is written right there in our slope. So every year you get a 92% pay increase at this place of employment, which is not a lot when you think about it. Okay, so the assignment is number 109, line of best fit on Alex.